Welcome back to Education Express, my dear friends. Let's continue with matrices. Last time we discussed relevant properties which were required for the purpose of solving exercise A and B. So we did the rules of addition, subtraction and multiplication of arbitrary constant with a matrix. What does that mean, sir? It means, supposing if you have a matrix A which is 4, 3, 2, 5, then we learned how to find out 5A. How, sir? You multiply each and every element of the matrix with 5. So it becomes like this: 5, 4, 3, 2, 5, which means 5 4s are 20, 5 3s are 15, 5 2s are 10, 5 5s are 25. This is called multiplication of matrix with any arbitrary constant or with any constant. So we know two matrices can be added if they are of the same order. Two matrices can be subtracted if they are of the same order. We also know different types of matrix. Row matrix set will have one single row. Column matrix set will have one single column, something like this. So this will be a column matrix. This will be a row matrix. Then we have a square matrix where number of column and number of rows will be same. Remember, my dear friends, the definition of the matrix is directly attributed to its order. Order is very, very important. You can't define matrix without its order, and order is always row into column. If you see the order of this matrix, there is one single row, so 1 into 3, one single column, and how many rows? 3, so 3 into 1, 2 row, 2 columns. So we need what is a row matrix, what is a column matrix, square matrix. Then we need what is a zero matrix, all elements are 0. We need what is a unit matrix, diagonally numbers will be 1. We need equal matrix. Two matrices are said to be equal if they are identical, homogeneous. We also did transpose matrix. What is that? So if A is 1, 2, 7, 9, then transpose of A denoted by A raised to T or A dash. Transpose of A, interchange rows to column. Row is 1 and 2, it becomes column. Row is 7, 9, it becomes column. So this is transpose of A. We did transpose. We also did additive inverse matrix. What is that? Matrix A plus matrix A inverse. That means additive inverse. Additive A will always result in 0. So example, if matrix A is 3, minus 7, 4 and 5. So additive of matrix A would be, please change all the signs. 3 will become minus 3, minus 7 will become 7. Each element will change in its sign. Minus 4 and this will become minus 5. So that when you add both of them, what you get is nothing but null matrix. All these things discussed earlier, I have given you simply a recap of everything. Now, when you move forward from here on, we have multiplication of two matrices. That means two matrices will multiply with each other, which we have not done so far. Example is matrix A is 2, 1, 3 and 4. I want to find out a product of A and B, whereas B is 3, 2, 0 and 4. I want to find out what is the product of AB. Matrix A multiplied by matrix B. So first and foremost, my dear friends, before you proceed with multiplication, there are many rules that you need to follow. First thing is, because since I want to find out product of AB, so make sure that you write A matrix first, which is 2, 1, 3, 4, and B matrix later, that is 3, 2, 0, 4. So done, sir. Done means it's not done. We have simply substituted. We don't know whether this matrix is possible or not possible. For the purpose of finding out whether AB will exist or it will not exist, we have to perform one small test, one small observation. So pay attention, what exactly is the observation? A matrix is defined by its order. Can anyone tell me what is the order of matrix A? Sir, it's going to be 2 into 2. And what about the matrix B? So even this will be 2 into 2. 2 row, 2 column. So write down here. 2 into 2, 2 into 2. Matrix A, matrix B. In short, while doing the sums, this is what exactly you will do. I am only asking you whether AB is possible or not. Does it exist or it does not exist? Answer is only that much. I am not asking you to compute what is the result of product of AB. No, I don't want that. I only want to know whether AB will exist or it will not exist. So I wrote the order, I wrote the order. Tell me, this is what? This 2 means row of first matrix and this is column of second matrix. This is row of first matrix, row of second matrix and column of second matrix. For the purpose whether AB exists or does not exist, it will exist if and only if these two numbers are same. That means number of column of A matrix should be equal to number of column of A matrix should be equal to number of rows of B matrix. If that is identified, here it is same, that is identified, that means it is 2 equals to 2. Therefore, AB will exist. It will exist. So my simple questions now would be, you only have to answer me whether it will exist or it will not exist. Matrix T, 3, 2, 5, 7, 6, 8. Matrix D, -2, -3, -4, -5, 6 and 7. I want to know if A, C will exist or not. A, C. A and C. Can anyone tell me what is the order of A? Sir, 2 into 2. What is the order of C? Sir, 1, 2, 3. 3 row and 2 column. 3 into 2. Sir, it is 3 into 2. Is this 2 and 3 equal? No. As number of column of A is not equal to number of row of B, which is 2 is not equal to 3. Therefore, AC does not exist. So my dear friend, you know the rules of the multiplication. First is to find out whether multiplication is possible or not possible. That means multiplication exists or does not exist. When it says it's not possible, what is the point doing multiplication? Because it does not exist means it is not possible only. It's absurd. So no point doing that. So before we try and operate on any product of two matrix to obtain a resulting matrix, ensure that this test is done before you proceed for any multiplication operation. Find out if CA exists. Let us find out if CA exists. Sir, if AC does not exist, how will CA exist? So my dear friends, the normal multiplication law, which is attributed to any arbitrary constant, the same laws does not apply to matrices. So don't ever tell me that if AB exists, so BA has to exist. Sorry my dear friends, it's nothing like that. There are chances that AB can exist and BA does not exist. In this example, as you saw, that AC does not exist. Let us try if CA exists or does not exist. So you'll have to write matrix C and matrix A. Can you please tell me the order of matrix C? See, the order is 3 into 2. So order is 3 into 2. What about the order of matrix A? Say it is 2 into 2. Wonderful. See this observation. This 2 and this 2 are same. So number of columns of C is exactly equal to number of rows of E, which is 2 equals to 2. Therefore, CA will exist. So you got the example? First part is to whether find out if the product of the two matrices exists or it does not exist. For the purpose of finding out that, you simply place the matrix in the order in which they has been listed above. A, B, A, B. What is the order of A? Mentioned. What is the order of B? Mentioned. Is these two same? Yes, sir. It will exist. A, C. What is the order of A? 2 into 2. So this is matrix A. This is matrix C. What is the order of matrix C? So 1, 2, 3. 3 rows, 2 columns. 3 into 2. Are they same? No, sir. The number of columns of A is not equal to the number of rows of B. 2 is not equal to 3. Hence, AC does not exist. Remember, I am repeating this again. If AC does not exist, does not mean that CA will not exist. In matrices, the rules are different. So you cannot say, okay, sir, 2 into 3 is 6. Therefore, 3 into 2 will also be 6. This law is absolutely right when you are doing operation on constant. But when you are doing operation on matrix, matrix is not a constant. Matrix is arrangement of numbers in rows and columns. And each number that is forming the part of this grid is called as an element. So, the rules of normal multiplication does not apply to the matrix multiplication. It depends on the order of the matrix because the personality or the identity of the matrix is dependent on its row and column. That is its arrangement. That is why I have been telling you the definition of matrix involves its pattern of arrangement, which can be ascribed in the norms of rows into columns. So main focus has to be on rows into columns. AB exists. Let us see if BA exists or does not exist. For the purpose of BA, I will write matrix B and then I will write matrix A. What is the order of B? So the order of B is 2 into 2. What is the order of A? So the order of A is 2 into 2. So both are same. B, A will exist. Sir, how come like that? AB exists, BA also exists. But AC does not exist. But CA exists. Yes, that all depends upon the arrangement of the order. Each matrix will decide for itself with which matrix I can gel. You cannot force anyone on me. I should decide or I should make a choice of my own friends. So just because someone is sitting next to me does not mean that someone is my friend. I will make a choice of my friend. In the same way, each of them will make a choice of their own matrix, whether they have the affinity for the other matrix to gel, the affinity to multiply and give you the desired product. Alright, so this was the first rule for finding out whether the product exists or does not exist. In case, if you get a green clearance, yes, sir, AB exists. Now I will show you how to find the product of the two matrices. Alright, so then how do we proceed further? Have a look over here. So we have matrix A 3, 1, 2, 5. Matrix B 4, -1, 3 and 2. I want to find out AB. So list down matrix A 3, 1, 2, 5, 4, minus 1, 3 and 2. What is the order of the matrix? 2 into 2. What is the order? 2 into 2. Mentally in your mind make sure that these two are same. Fantastic. That means you are going to get product of these two matrices, which will be one single matrix. Now you are going to get matrix AB. You know what will be the order of matrix AB? Yes, sir. The order can be obtained. These two are same. It will go away. The order of the resulting matrix is here only. The first and the last. That means this matrix will also be of the order 2 into 2 only. Now how to obtain that? Have a look over here, my dear friends. Have a look. Since you have A, B, C, D, P, Q, X and Y, how do we go about? We start with this row. So we'll go this row. This row will multiply by this column. Oh, this row multiply by this column. Row into this column. So if you see over here, the first term, this row. So 3 and 1 will get multiplied by 4 and 3 corresponding. 3 will go to 4, the first term and the first term, the second term and the second term. So this row into this column. So 3 multiplied by 4, that's not the end, 3 into 4, plus 1 into 3. Now you can say you obtain this term. This row, see the arrow, and this column. Since this row already done with this combination, so same row will move on to the second one. That means this one. What we did with this, same thing this arrow will do with this column also. So how? 3 into minus 1. 3 into minus 1. That is minus 3. So you can write it down. 3 into minus 1 plus. So how we are going? This into this, already done. Now this into this. So A will go to Q. So 3 will go to minus 1. There is one more term left. 1 will go to 2. Concentrate and do it. Discipline yourself. So this is done. This is done. It means, sir, this row got an opportunity to mingle with this. This row got an opportunity to mingle with this also. So now this row is of no use to us. Out. So this row is permanently out. How this row got an opportunity to mingle with both of them? Same way, now this row will get an opportunity to first mingle with this and then mingle with the other one. So how do we go about? Now this row, we'll start with this row. 2 and 5. So 2 and 5 is going to get multiplied with 4 and 5, same way. So 2 into 4 plus 2 into 4 plus 5 into 3. Done. Since this row got an opportunity to multiply with this column, now this row will get an opportunity to multiply with another column. 2 into minus 1 plus 2 into minus 1. 5 into 2. What is the result of matrix AB? 3 into 4, 12. 12 plus 3, 15. 3 into minus 1, that is minus 3, plus 2, that is minus 1. 2 into 4, 8. 8 plus 15, 23. 2 into minus 1, minus 2 plus 10. Minus 2 plus 10. So this is my matrix AB. Wow. Sir, can you please show us one more time? Of course, yes. Why not? Assume there exists matrix C also, which is 4, 1, 3 and 2. Okay. So how we are going to do this? I want to find out matrix AC. So please bring A and bring C. Matrix A 3, 1, 2, 5. Matrix C 4, 1, 2, 3. Whether it will exist or not. Order 2 into 2. Order 2 into 2. These both are same. So they will cancel. That means, sir, AC will surely exist and it will have the order 2 into 2. You can check it. It will have the order 2 into 2. Yes, it is having the order 2 into 2. So how do we go about? Very simple. Start with the first row and the first column. First row, first column. 3 into 4, not yet over. 3 into 4 plus 1 into 2. Absolutely done. So first row into first column, complete. Same row, because it has to complete with all the rows. Same row. Now we'll move with this column. So what you will say? 3, this, erase this, because we should know now it's going to multiply with this. 3 into 1 plus 3 into 1 plus 1 into 3. Absolutely fine. This row done with this combination. This row done with this combination. That means now you need to discard this row. Out. What you did with the first row, same thing now you are going to do with the second row. This row and this combination. So 2 into 4 will be 8 plus 2 into 4 plus 5 into 2. 5 into 2. So then, since we are doing this row already multiplied with this column, so we will shift on to the next row. So next column. So start with this arrow. So 2 into 1 plus 5 into 3. So start 2 into 1 plus 5 into 3. When you actually practice, you will understand how exactly this needs to be executed with lots of discipline. 12 plus 2, 14. 3 plus 3, 6. 8 plus 10, 18. 2 plus 15, 17. We got, sir, can you please do one more time? I am still not confident, but if you do 2-3 times, sir, I will feel more confident about the same thing. Okay, no problem. Let us find out BC. If BC exists or no. So you need to note down B, you need to note down C. So with that, what is the value of B? 4, minus 1, 3 and 2. C will be 4, 1, 2, 3. Let us start. What is the order? 2 into 2. What is the order? 2 into 2. Are they same? Yes, sir. So the result, it will exist and the resulting matrix would be 2 into 2. We begin with this row and we begin with this column. Begin with the row. 4 4s are. Perfect. Plus minus 1. Have a look. I am going this way and this way. This is done. So now minus 1 into 2. That is 2 into minus 1. What I will call it? So minus 1 into 2. Done. This row with this column is done. Same row with this column. Same row with now this column. So 4 into 1 plus minus 1 into 3. Minus 1 into 3. This row got an opportunity with this. This row got an opportunity with this. There are no further columns, so this row has to expire forever. Shift to the next row. 3 into 4. 3 into 4 plus 2 into 2. So this row you did with this column, it's done. Now it will shift to another column. 3 into 1 plus 2 into 3. How we are going? This into this. So this means 3 into 1 plus 2 into 3. That is what exactly we are doing. Alright. So what will be the outcome? 16 minus 2, 14. 4 minus 3, 1. 12 plus 4, 16. 3 plus 6, 9. We got the answer as BC. Sir, since we found out BC, can you find CB? I can try. We can try finding CB. Many people may be wanting to know whether the result of BC and CB is same or it is not same. My answer would be, okay fine, before I predict my answer, let us solve and see by ourselves. We found out BC, let's find out CB. C and B. So what is the value of C? 4, 1, 2, 3. What is the value of B? 4, minus 1, 3 and 2. What is its order? 2 into 2. What is the order? First thing, order. Since these two are same, so CB is possible. It is possible also and the resulting answer would be of the order 2 into 2. So how do we go about? Same way. Start with the row over here and column over here. 4 into 4. Not done yet. This into this plus 1 into 3. That is how all the elements of the row is covered, all the elements of column is covered. After doing the first one, move on to the second row. 4 into minus 1. 4 into minus 1 plus 4 into minus 1 plus 1 into 2. 1 into 2. Initially, you are using this pattern of drawing a column or an arrow. Slowly and gradually, it will become so mechanical that you will get used to it and you will not need to draw these arrows also. First row has been taken care of. Now the second one. Second one will start with this. Alright. So 2 into 4. 2 into 4 plus 2 into 4 plus 3 into 3. Next, so since this is done with this, we'll move on to the next column. 2 into minus 1. Yes, 2 into minus 1 plus 3 into 2. 3 into 2. When you actually do this, what you get is 16 plus 3, 19. What you get? Minus 4 plus 2. So minus 4 plus 2 will be minus 2. 8 plus 9. 8 plus 9, 17. Over here, minus 2 plus 6. Minus 2 plus 6. This is CB. This is BC. Are they same? No, sir. That is the conclusion. That is the conclusion. That means what we observed over here is BC is possible, CB is also possible, but they both are not same. These are the laws of multiplication. My dear friends, if you practice and understand these laws of multiplication, entire exercise will become extremely simple. What you need to know is the rules of the matrix multiplication. Once those rules are done with, I think you will be absolutely fine with it. Take for example, if I have matrix A, which is 3, 2, 5, 1, matrix B, which is minus 1, 3, 2 and 0, and I am interested in finding out matrix A, B. How do we go? So first place matrix A and B respectively. 3, 2, 5, 1, minus 1, 3, 2, 0. What is the order of the matrix? 2 into 2. About the order of the matrix B? 2 into 2. Since these two numbers are same, therefore matrix AB, the product of AB, will exist. And what will be the resulting order of the matrix? That is the remaining one, 2 into 2. How do we go about? So very simple. Start with the row. This row from here will get multiplied by this column. 3 into minus 1, minus 3. Plus 2 into 2, 4. So this row done with this column, same row with the next column. 3 3s are 9. Plus 2 into 0, 0. So my dear friends, this row is done with. We'll move on to the next row. Next row, again the first one. 5 into minus 1, minus 5, plus 1 into 2, that is 2. Next one, 5 into 3, 15, plus 1 into 0, 0. So my dear friends, here we go and we get matrix AB. You just need to do addition, subtraction, operation and you get your answer. Now someone asked me, sir, in case if I want to find out, since A is available, A is 3, 2, 5, 1. I want to find out A square. You know what would be the misadventure? Misadventure would be in case if you directly do the square. If you write this, it will be wrong. It is inappropriate. It is wrong. Matrix multiplication of A square would mean matrix A multiplied by matrix A and not this. That means matrix A multiplied by matrix A, 3, 2, 5, 1, 3, 2, 5, 1. So when you multiply, what do you get? 3 into 3, 9 plus 2 into 5, 10. Same way, same method of multiplying. First row, first column. First row, next column. 3 into 2, 6 plus 2 into 1, 2. So I have done with the first row, first column, first row, second column. Leave the first row. Move on to the next row. 5 3s are 15 plus 5 into 1, 5. Done. 5 2s are 10 plus 1 into 1, 1. And what do you get? Please do the addition subtraction operation. Here we have only additional operation. 19, 8, 20 and 11. So this is how we can find out the value of a square. In case if you wish to find out value of b square, it will be b multiplied by b. What is matrix B? Minus 1, 3, 2, 0. Minus 1, 3, 2, 0. How you go about? Sir, the order is 2 into 2, 2 into 2. These two are same. Therefore, the resulting order would be 2 into 2. Let's go about. Row minus 1 into minus 1, 1. Plus minus 1 into minus 1 is 1. Plus 3 into 2 is 6. Absolutely right. Again, same row, the next one. Minus 1 into 3, minus 3. Plus 3 into 0, 0. After that, the next row. 2 into minus 1, minus 2. Plus 0. And the next one, 2 into 3, 6. Plus 0. So my dear friends, what do you get? 7, minus 3, minus 2 and 6. This is the value of b squared. So with this, we very well know, or we are well versed with finding out the value of square of any matrix. Now in case, supposing, let us say if I am modifying my question a bit, then if I say something like this, I want to find out the value of 4i. Sir, a is available, b is available, I is not available. How do I get I? So I hope you remember, I stands for identity matrix. Yes, my dear friend, it stands for identity matrix. What does that mean? So identity matrix is also called as unique matrix. Perfect. And it means 1, 0, 0, 1. So diagonally you will have 1. So if you find out 4i, what you need to do? 4, 1, 0, 0, 1. Can you multiply that? Of course, sir. 4, 0, 0, 4. So my dear friends, this becomes as simple as any other matrix multiplication. In fact, more simpler than that. And we are able to find out the value of 4i. Supposing if I modify my question a little bit further, and if I wish to find out the value of, let us say, a square minus 3a plus 4i will be how much? So the answer to this question would be a square would mean a into a, matrix A into matrix A, minus 3 into matrix A, plus 4 into matrix I. Now A into A would mean 3, 2, 5, 1, 3, 2, 5, 1, minus 3, matrix A, 3, 2, 5, 1, plus 4, I is an identity matrix, 0, 1. My dear friends, A into A, that is A square. I have already found out the value. What is the value of it? So the value is 19, 8, 20 and 11. Excuse me. Minus 3. Can I take this 3 inside? Of course. 3 3s are 9. 3 2s are 6. 15 and 3. Plus 4i. I already found out the value. Still you can find out 4, 0, 0 and 4. So finally what you get is 19, minus 9 plus 4. What over here? 8 minus 6 plus 0. Absolutely right. 20 minus 50 plus 0. Exactly. 11 minus 3 plus 4. So your final result of the matrix would be 19 minus 9, that is 10. 10 plus 4, 14. 8 minus 6, that is 2. 2 plus 0, 2. 20 minus 15 is 5. And 11 minus 3, 8. 8 plus 4, 12. So basically, we are very well versed and familiar with matrix multiplication. Now supposing if I extend one step further from here, and if I ask you to find out the value of the matrix A plus B the whole square. Find out. Also find out A square plus B square. How do you go about? Sir, if I have to find out A plus B the whole square, first thing is I'll find out matrix A plus B. Can you find matrix A plus B? Yes, sir. Matrix A is 3, 2, 5, 1. Plus, so in between plus sign. Matrix B minus 1, 3, 2, 0. Matrix B. Can we do addition of the matrix? Yes, sir. Two matrices can be added provided they are of the same order. Matrix A and B, they both are of the same order. So we can add them. Let us see how we add them. 3 plus minus 1, that would mean 2. 2 plus 3, that is 5. 5 plus 2, 7. 1 plus 0, 1. So we got matrix A plus B. What do we have to find? A plus B square. A plus B square would mean matrix A plus B multiplied by matrix A plus B. Do we have matrix A plus B? Yes, sir. We just found out. Fantastic. 2, 5, 7, 1. Again. 2, 5, 7, 1. I am sure, my dear friends, from here on, you can take up whether this multiplication will be possible. Of course possible, sir. The order is 2 into 2, 2 into 2, so it will be possible. So let's go ahead and carry out the multiplication operation. 2 2s are 4, plus 5 into 7, that's 35. Next, 2 into 5, 10, plus 5 into 1, 5. 7 into 2, 14, plus 7 into 2, 14, plus 1 into 7, that's 7. Again, 7 into 5, 35, plus 7 into 5, 35, plus 1 into 1, 1. So ultimately, we get the answer to A plus B the whole square. 39, 15, 21 and 36. This is how we can obtain A plus B the whole square. Someone asked me, sir, how are you going to do this? A square plus B square. My answer is, I will solve A square by following the same thing what we did before. What is that? We will find out the value of A square by actually multiplying matrix A into A. 3, 2, 5, 1. So 3, 2, 5, 1 into 3, 2, 5, 1. You know the logic of multiplying two matrix. The resultant matrix will be 19, 8, 20 and 11. Similarly, we can find out matrix B square, which would mean matrix B multiplied by matrix B. B is minus 1, 3, 2, 0. Minus 1, 3, 2, 0. Is B square possible? Sir, since the order is 2 into 2, 2 into 2, so of course yes, it is possible and it will exist. Next, multiply minus 1 into minus 1, 1, plus 3 into 2, 6. Next one, minus 1 into 3, minus 3,
plus 3 into 0, that's 0. 2 into minus 1, minus 2, plus 0 into 2, that is 0. 2 into 3, 6, plus 0 into 0, 0. So my dear friends, you get 7 minus 3 minus 2 and 6. So we have found out the value of b square. Your a square value is this, your b square value is this. Appropriately, if you are interested in finding the value of a square plus b square, what we can do is we can simply substitute the value a square plus b square. We already found out the value of a square, and now we found out the value of b square as well. We have to find out a square plus b square. What I am going to do is I am going to substitute the value of the matrix a square and b square. So a square plus b square. What is the value of a square? 19, 8, 20, 11. B square 7, minus 3, minus 2 and 6. Of course, when you do so, 19 plus 7, that's 26. 8 plus minus 3, that is 5. 20 minus 2, 18. 11 plus 6, 17. With this, my dear friends, you are thorough with matrix multiplication, and I assure you, within the domain of the knowledge that we have discussed so far, you will be able to solve any complex question